Hi, my name is Bryce Bradshaw, and I will be presenting for our group, which includes me, Cesar Rosales, and Maximus Carrillo. Okay, so our hypothesis was that spiral galaxies are more likely to collide with other galaxies as opposed to elliptical ones. We believe this because spiral galaxies are always moving, and from what we could see, it just looked like elliptical ones didn't really move like spiral galaxies do. So we just believe that since spiral galaxies are always on the move, they're more likely than elliptical galaxies to collide into other galaxies. So local density measurement. What is local density? Local density is a log of the measure of the environmental density. So what that means is how many nearby neighbors there are within a certain distance. The higher the number, the more nearby neighbors. So we use this data to find if the galaxies in question had a high number of nearby neighbors, in the sense that although they're nearby, quote unquote, the galaxies were still hundreds of millions of light years away. So this is a spiral local density data. We had a histogram. So what it shows is that the data is that more often spiral galaxies aren't that close to other galaxies, but they do sometimes get near other galaxies. But what is interesting about this data and how it compares to the other data is that ellipticals, it shows that there are less ellipticals than you would think there would be for millions of galaxies. However, there are a number of uh, galaxies that are close by to ellipticals, and because the ellipticals are close by to the other galaxies, it just shows that maybe they do have the potential of being, colliding into other galaxies. The data also shows that they are less frequent than spiral galaxies, which was also surprising to us because we expected there to be an even number. Near cluster measurement. Near cluster measurement is also another factor that we used in the distance. It is the distance of the nearest cluster of galaxies. So again, we use this to factor in which of the galaxies tend to be closer to the other galaxies. Again, realizing that close means hundreds of millions of light years away. So side-by-side comparison of spiral and elliptical near cluster data. The one on the left is spiral galaxies, and the one on the right is elliptical ones. From what we can see, both of them look very similar. It just again happens to be that there are more spiral galaxies than there are elliptical ones. This is probably due in part to the people who identified them. It is possible that some of the identifications were wrong, due in part to human error, and maybe if we get further into the future, that some of these ellipticals turn out to be spirals, and some of these spirals turn out to be ellipticals. But the data does show that they're roughly the same, so it kind of really doesn't make a difference in how close they are. So they all tend to be kind of close to each other um, when they are nearby to other galaxies. So in conclusion, our initial hypothesis about spiral galaxies being more likely to collide into other galaxies was wrong. We did learn that elliptical galaxies are more likely to collide with something else, thanks to their local density data. And with this information, we concluded, although elliptical galaxies have a slight advantage compared to spirals of colliding, we know that this phenomena is particularly rare, and so we humans won't see it in our lifetimes ever. But we do know later on in the future, perhaps, that they have a better chance of colliding into other galaxies than, say, spiral galaxies.